All right, so the graph here gives the velocity function. What's the best estimate of the distance traveled by the car? So you know that distance is the area under the velocities. Displacement is the integral of velocity. So we can just do our best to estimate the area here, even though it's not a nice shape, a shape that we recognize, but we can kind of just pretend like we are just adding a bunch of rectangles together that may be close to the area. Here is 50 times 3, 50, 30. I got 10. Okay, so I added to be about 200 here, and that's closest to 210. So just trying to find areas of rectangles that add up to be what I see there.
Okay, so you just find the area for that one pretty much.
Okay, 84. Between negative 1.5, 1.5, you got F prime to the following. That is the graph concave down. So you know that you can sketch the graph, look to see where negative slope occurs. Wherever negative slope occurs on the F prime graph is where the graph is concave down. So I can just sketch my graph in my calculator. Let me zoom in a bit here. I can trace. Okay, so between negative 1.5 and negative 1, we see negative slope here, and also between 0 and 1. So wherever negative slope is on the derivative graph, the first derivative graph is where we're going to experience concave down. Okay, 85. The graph of the derivative is shown. I like to go ahead and label what I'm looking at. This is not the original shape of the graph. This is the derivative graph. So we have to label and understand what we're looking at here. So above the x-axis is positive slope of the original graph. Below the x-axis is negative slope of the original graph. On the x-axis is slope 0. So we see that the x-intercept is what we really care about. -3 and 1. And then below is negative slope, positive slope in between, and negative slope for the remaining portion. So we're expecting a relative min at -3, a relative max at 1. So relative max is at 1. Okay, next up, f prime is greater than 0 for all numbers. And the integral from 4 to 7 of f of t dt equals 0, which of the following could be the table of values for the function. So if f prime is greater than 0, that means we're hoping that the slope of our graph is positive, right? That means the graph is always rising. And then the integral from 4 to 7 is equal to 0. So that means there must be regions above and below the x-axis in order for this total to be 0, right? That means the area beneath the x-axis and the area above the x-axis must equal. Otherwise, that's the only way we can get 0. If we have a positive and negative region added together, that are the same. So we can kind of just look at our order pairs here to make that match. We see that the order pair is increasing. And also, we want regions above and below the x-axis. This is just below, nothing above. Not enough below, too much above. Okay, and this is just going to be 0 here. So B is going to be our best choice. So sometimes if you don't know what you're working with, just sketch the graph out. I think that is the best indication to help you visually see what could be the best fit. Okay, 87, we have the second derivative graph shown. So understand that the second derivative graph, the y-axis represents concavity. Of the original graph. Y-axis does. So anything above the x-axis is going to mean concave up. Anything below the x-axis is concave down. Anything on the x-axis is a potential point of inflection. So inflection, critical points at -1, 1, and 3. Below is concave down. Above is concave up. Concave down, concave up. So we're looking for intervals where the graph is concave down. So from -2 to -1, and from 1 to 3. This is part of the calculator portion of the test. You can see some of these problems don't require a lot of work, and so I find a lot of students having too much time on this portion of the test. There's only 15 questions, but you have 45 minutes to work on it, and so yeah. So I feel like a lot of times we don't need all that time, but that's just the way they designed it. Okay, we got the shadow problem here. So we can create a triangle within a triangle. Height of the street light is 15. The person is 6 feet tall. We have X and Y. Okay. Set up our proportions. The height of the small triangle is the height of the large triangle as the base of the small triangle. is the base of the large triangle. Make sure it's y over x plus y and not x over x plus y. Cross multiply. So 6 dx dt, 9 dy dt. Once you find the derivative, this is our related rates problem. Dx dt represents the rate of change of the person walking. Dy dt is the length of the shadow increasing. And if I add the two rates together, that's the rate of change of the tip of the shadow. But it's only asking for the shadow length increasing. So we see that the height, we see that the person is walking away at a rate of 4 feet per second. So you know that dx dt is positive 4. So plug 4 in for dx dt and you solve for dy dt. So 24 over 9, it'll be your dy dt. Which is 2.667. Particle moves along a line so that its acceleration is given by a of t. Particle's velocity, t is 0 is 5. What's the velocity? So we can use our formula that we've been using a lot, which is final position equals initial plus displacement. But we can adapt it for velocity. We can say final velocity equals initial velocity plus displacement of velocity. So v of b equals v of a plus displacement of velocity, which is change of velocity integral from a to b of a of t. So once you set this up, it's easy. Just plug in the calculator. Our initial velocity is 5. From 0 to 3, there's a change in 6.7 for velocity. So 5 plus 6.7 equals 11.71.
Mr. Yang,
Yes.
I have a question. So on number 15, how did you get the equation y over x plus y?
Right. So we're doing proportions here. So you can say that the height of the large triangle is to the height of the height of the small triangle is to the height of the large triangle. And then the base of the small triangle is the base of the large triangle. So the base of the small triangle is y, and the base of the large triangle is x plus y.
Oh, okay.
Right. Because I can't say x over x plus y, because x is not the full base of any triangle. Does that make sense?
Yes, that makes sense. Mr. Yang, I have to head out right now because I have to get ready for school. But
Sure,
thank
no
you for the
problem.
review.
Yeah. Okay, so number 90.
Or a calculator for the apes exam.
Yeah, you just grab one. Integral from 6 to 12 of f of 2x dx equals 10, which is the following must be true. We can go through use substitution to make that 2x go away. So if I want to do f of u, I can pull that 1/2 over. So multiply both sides by 2 to get that 1/2 to come over to the other side. And then we also need to adjust the bounds because we've converted this in terms of u. So we got to plug the 6 in for the x. So we get 12. And we got to plug the 12 in for the x, convert it all to be the same variable. So from 12 to 20. All right, 12 to 24. Okay, 91, let f be the polynomial with values of f prime for selected values, which of the following must be true. So it helps if we can just sketch this graph out to see what we're dealing with. So you see that all these values are sitting above the y-axis. And we see that based off of how this graph is showing, there must be at least 2 points of inflection because the way that we graph this here, there's got to be 2 peaks and valleys, or 1 peak and 1 valley. If that's the case, any peak and valley will be a POI. We could say that function is increasing if it's always above the x-axis, but we can't guarantee that because this graph may dip below the x-axis that we don't know about, but it also may stay above, so we can't guarantee that. It's possible it has no critical point, that's true, but it could also dip below. So we have to understand that we're not seeing the entire graph. We just have points around the graph. So I'm just sketching out a possibility, connecting those points, but understand that there could be a lot of different things that's happening that we don't know about. But no matter how we draw the graph, we gotta at least have 2 points, a min and a max, a peak and a valley, no matter how we draw it. So this we can guarantee. Okay, 92. Okay, so R is the region in the first quadrant. We have y equals root x. That's the curve above. You have y equals square root of x. This is the graph below. Cross section perpendicular to the x-axis. So we want to draw something that is vertical. We know it's going to be a square. So let's first build the base. Base is going to be top minus bottom, root x minus x squared. Area of a square is base squared. And then we find our bounds 0 to 1, and we just plug into our formula. So we always, with cross section, we build it dimension by dimension. So we start off with the 1-dimensional base, then 2-dimensional area, and then put the interval around it that gives that 3rd dimension. Okay, page 17. Integral from 2 to x of 3t squared minus 1. Just treat it like a power rule problem. And then we can work in the bounds once we do power rule. Okay, theories cancel out. Plug in the x first. Eight minus 2 is 6. X cubed minus x minus 6. Okay, what's the slope of the line tangent to the graph? So let's find the derivative and then plug in the 4 into the derivative. So the rule for natural log is u prime over u. Two over 2x is my derivative, which would just be 1 over x. So y prime of 4 is simply 1/4. Again, find the derivative using power rule and then plug in 2. Negative 1 plus 1 is 0. Integral from 1 to 2, dx over 2x plus 1. There's a little bit of u substitution. There's too many terms in the denominator. We can't just expand and use power rule. Upper bound first. And then lower bound. Okay, which of the following statements is true? Limit as x approaches 2 from the left side of 2. So that means I'm taking a point to the left of 2, headed towards 2. Okay. It is approaching the same value as f of 2, so this is true. Approaching 6 from the left and from the right. So pick points on either side of 6. Head towards 6. They're both headed towards the same y value. That's true. Limit exists there. Limit as x approaches 6 does not equal to f of 6, though. So here the limit is approaching -1, but f of 6 is at -3. So this is not in agreement. So only 1 and 2. Okay, derivative of sine cubed of x squared. So we got to be careful here. Anytime we have a trig function with that shorthand notation, it's best to write it out with that bracket outside. Then you can clearly see the need for chain rule. Outside, inside. Outside's derivative. 3 bracket to the second power. Keep the inside alone. Sine of u becomes cosine of u times u prime. Clean this up here. 3 and 2 can multiply together to be 6x. What they did was they brought the 2 back in shorthand form. Okay. Plug in the limit. Here, x cubed over e to the 3x. If we do comparative growth rates, we know that exponential is growing at a faster rate than the polynomial. So you know that this will go to 0. But you can also do L'Hopital's rule if you get infinity over infinity. So if you keep finding the derivative here, you get 3x squared over 3e to the 3x. Okay, still infinity over infinity. Keep going, you get 6x over 9e to the 3x. Still infinity over infinity. And then finally 6 over 27e to the 3x. Finally, you're going to get 0 over infinity, which is 0. Yeah. So you know how L'Hopital's rule says that if you get 0 over 0, you can keep finding the derivative. L'Hopital's rule also applies for infinity over infinity. So if I do derivative here, I get 3x squared over 3 to the 3x. If I plugged in infinity, I still get infinity over infinity. So every time I get infinity over infinity, that gives me the green light to do another round of L'Hopital's rule. So 6x over 90 to 3x is still infinity over infinity. And finally, I get 6 over 20, sorry, 26 over 27 e to the 3x. That's really 6 over infinity. If I have 6 over infinity, that's really a really small fraction, which is approaching 0. And then the other method is understanding that the denominator is an exponential, and then the numerator is a polynomial. So comparative growth rate says exponential grows at a faster rate than the polynomial. So if the denominator is increasing at a faster rate than the numerator, then your limit is going to be 0. Okay, last problem here. Using U substitution. Let's see if we can get something equivalent to what we have here. So we'll let the U value be the portion inside that sign, the sign 2x, but it's best to pull out that exponent first to clearly see it in context, and then we can let our U value be sine of 2x. Du dx is cosine of 2x times 2. Find the solve for dx, which is du over 2 cosine of 2x. Make your substitutions. This becomes u. Dx becomes 2 cosine 2x. Cosine 2x cancels out. Push the 1/2 out in front. We're not going to go any further because we want to match it up with this form. But notice that your integrand is in terms of u, so you have to convert your bounds as well. So we can plug that power of 6 in for x. Sine of pi over 3 is root 3 over 2. Sine of pi is 0. So root 3 over 2 to 0. And it's going to be the equivalent of our starting problem.